Welcome. In this video, we'll walk through a common algebra problem involving binomial expansion. By the end of this lesson, you'll be able to solve for an unknown coefficient by expanding a binomial and comparing it to a given expansion. Let's look at the problem we'll be tackling today. We are given that the expansion of the binomial quantity x plus b, all cubed, is equal to the polynomial 8x cubed minus px squared plus 18x minus 3 square root of 3. In this problem, a, b, and p are all real constants. Our goal is to find the value of p. To do this, our strategy will be to expand the left side of the equation, the binomial x plus b cubed, and then compare each term of our result to the corresponding term in the given expansion. This comparison will allow us to find the values of a, b, and eventually p. Let's begin by expanding the binomial, x plus b3, using the binomial expansion formula. The formula for the cube of a binomial is quantity x plus y, all cubed, equals x cubed plus 3 times x squared y plus 3 times xy squared plus y cubed. Now we will apply this formula to our specific binomial, x plus b3. In our case, x from the formula corresponds to x in our problem, and y from the formula corresponds to b in our problem. We will substitute these values into the formula. I'll write out each term clearly as we go. The first term is x cubed, which is x. The second term is 3 times x squared times y, which becomes 3 times x2 times b. The third term is 3 times x times y squared, which is 3 times x times b2. And the fourth term is y cubed, which is b3. Now, let's simplify this expression by expanding the powers and rearranging. For the first term, x3 is a3x3. For the second term, x2 becomes a2x2. Multiplying by 3 and b, we get 3a2bx2. For the third term, b2 is just b2. Multiplying by 3 and x, we get 3abx, and the last term remains b3. So, our full expanded expression is a cubed x cubed plus 3, a squared bx squared plus 3, a b squared x plus b cubed. Now that we have the expansion, our next step is to compare it to the expansion given in the problem. We have two polynomial expressions that are equal for all x. The only way this can be true is if the coefficients of corresponding powers of x are equal. Let's compare them term by term, starting from the highest power. Look at the x cubed terms. On our expansion, the coefficient is a cubed. In the given expansion, it's 8. So, we can set up the equation. A cubed equals 8. Now let's compare the constant terms. These are the terms without an x. In our expansion, the constant term is be cubed. In the given expansion, it's negative 3 square root of 3. This gives us our second equation. b cubed equals negative 3 square root of 3. Let's compare the x terms next. Our expansion has the x term with a coefficient of 3ab squared. The given expansion has a coefficient of 18. This gives us our third equation. 3ab squared equals 18. Finally, let's look at the x squared terms, which involve pe. In our expansion, the coefficient of the x squared term is 3a squared b. In the given expansion, it's negative p. So our last equation is 3a squared b equals negative pe. This is the equation that will give us the answer we're looking for. We've successfully created a system of 4 equations with 3 unknowns, a, b, and p. We can use the first few equations to find a and b, and then substitute those values into the last equation to find p. Let's solve for a and b using the equations we derived from comparing the x cubed and constant terms. We have the equation a cubed equals 8. To find a, we just need to take the cube root of both sides. The cube root of 8 is 2. Therefore, a equals 2. We've found our first constant. Now let's find the value of b using the constant term equation. Our equation is b cubed equals negative 3 square root of 3. To find b, we take the cube root of both sides. So, b equals the cube root of negative 3 square root of 3. This looks a bit complicated. Let's see if we can simplify it. Sometimes, with these types of problems, one of the later equations can give us a simpler way to find one of the variables. Let's hold on to this expression for b for a moment and see if we can find a simpler path. This brings us to the next part of our process, solving the system of equations. Our goal is to find p, and the equation for p is p equals negative 3a squared b. We already have a, which is 2. If we can find b in a simpler way, our calculation will be easier. Let's re-examine our system of equations. We found a equals 2. We have the equation for b, but it looks complex. We also have another equation. 3ab squared equals 18. This one looks promising. Let's work with the equation 3ab squared equals 18. We know the value of a is 2. Let's substitute that into this equation. Substituting a equals 2, we get 3 times 2 times b squared equals 18. This simplifies to 6b squared equals 18. Now we can solve for b squared by dividing by 6. So b squared equals 3. This gives us b squared, but we need b for our p equation. Taking the square root, we get b equals plus or minus the square root of 3. This gives us 2 possible values for b. So we've established that a equals 2 and b equals plus or minus the square root of 3. Our goal is to find p using the equation 3a squared b equals negative p. Wait, we have 2 possibilities for b. Which one is correct? We must go back to our earlier equation. b cubed equals negative 3 square root of 3. Let's test both possibilities for b with this equation. Case 1. Let's assume b equals the positive square root of 3. Then b cubed is the square root of 3 cubed. This is the square root of 3 times the square root of 3, which is 3 times another square root of 3, which gives us 3 square root of 3. But our equation is b cubed equals negative 3 square root of 3. Since 3 square root of 3 does not equal negative 3 square root of 3, we know that b cannot be positive square root of 3. This possibility is incorrect. Now let's test our second possibility. Case 2. b equals the negative square root of 3. Then b cubed is the negative square root of 3 cubed. This is negative 3 square root of 3. This matches our equation perfectly. So we have found the correct values for our constants. The constants are a equals 2 and b equals negative square root of 3. These are the values that make all of our comparison equations hold true. We've done all the hard work. We have our constants, a equals 2 and b equals negative square root of 3. Now we can find pt. Our equation for p was 3a squared b equals negative p. We can rewrite this to solve for p directly. p equals negative 3a squared b. All we need to do now is substitute our values for a and b into this equation. So p equals negative 3 times a squared, which is 2 squared, times b, which is negative square root of 3. Let's simplify this step by step. First, 2 squared is 4. Next, negative 3 times 4 is negative 12. Finally, negative 12 times negative square root of 3 gives us positive 12 square root of 3. And there you have it. We have found the value of p. The value of p is give square root of 3. Let's quickly recap what we did to solve this problem. First, we expanded the binomial on the left side of the equation using the formula for cubing a binomial. Second, we compared the coefficients of our expanded form with the coefficients of the given polynomial, setting them equal to create a system of equations. Third, we solved for the constants a and b by using the simpler equations from our system. And fourth, we substituted these constants into the equation involving p to find its value. This method of expanding and comparing coefficients is a very powerful technique in algebra, and you'll find it useful in many different areas of mathematics. Now you are able to solve for an unknown coefficient by using binomial expansion and polynomial comparison.